Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Gamers and coders, Happy New Year! This is the first day of the new year, and on the last day of 2017, I finished something that I'd been working on for a short while, but something that's been in my head for a longer time. I'm going to run through some coding that has to do with smooth scrolling characters. Usually, when I think of smooth scrolling, I think of using the hardware scrolling that the VIC chip provides, and I've done that, but I saw a little clip of Solus 2 that Trevor Story uploaded, and I'll show it here. I'll have to get me out of the way, which I will do. There I go. Whoop. And as you will see, right about here. Oh, here. See that? So, I'll start. Basically, there's a small section of the screen that has scrolling characters. So this section of the screen is scrolling it. And when you use the VIC-2's hardware scrolling, you use at least the entire width of one line, and you can limit the number of lines by using the raster to time when you are going to do that. But you're always using a full line to scroll, and this is just a small section. So I actually asked Trevor, how the hell do you do that? He said, well, I just tell Georg to do it and it appears. So I had a little think about it, and I thought, well, basically it's like a little ticker. And you can do that by redefining the character set, which I've done, and I've managed to do that. But this is where I started thinking, I want to try and make this happen. So I sort of worked on it, and I didn't do anything for a long time with it. I'll make myself a little bit bigger again. Whoop. And then I saw Ray, G-Ray Defender, Gray Defender. I'll put a link to his YouTube channel in the description, who did exactly that. And I think he based his idea on things that he saw on the development of Galencia, which is a really good game by Jay Aldred. That's beside the point. But he did a similar video to what I'm doing right now. There's two things I want to say before I go into it. It was fun to see that Ray, I'm going to call you Ray, but I don't know if that's your name, had the same idea and the same thought to do a video like that. But it's pure coincidence that we're doing that at the same time. I haven't looked at his code. I haven't taken his code and changed it around and said, oh, okay, now I've got it. I'm doing this as an exercise for myself to see if I can go from the idea of seeing that in Trevor's video to actually doing it. I'm also not saying that my code is better than anyone's. If anything, this code is not optimized. It's not the best way. I use Georg's style even because that I borrowed some of the code from Supernatural, which is what I'm still working through. So it's got nothing to do with Ray's video. It's just a coincidence that we're doing the same thing at the same time. Now, I'm going to make myself small again. There we go. Oh. Not out of the picture, please. So, like that. Here's my code. I want to show first the basics of what we're trying to do. Then I'm going to explain a little bit about how it works. All right. Okay, so this is, I'm going to run the code, and you'll see a little text saying, hello, this is my message. Soft scrolling, and it's a little section of the screen. I could place this anywhere that I want, basically, and I can make it faster and slower. But this is the idea, right? I can even move it to a different location. Anyway, I won't do that. Let's talk about how it's done. So basically, I'm building a ticker, and to do that, I designate some characters that I'm going to redefine. I'm going to have a message, and I'm going to map. I'm going to take the shape of each character in my message and copy it to the redefinable character, or the ones that I use for the ticker. And then all I'm going to do is use the roll command, like shifting all the bits one bit to the left in the ticker set. Whatever their shape is, I'm just going to roll it left in an infinite loop, basically. That's the basic idea. Now I'm gonna go through the code and try and make sense of how it works, or at least how I've done it. It's the first thing and the most important thing to realize is that I'm going to have to redefine the character set. And to do that, I have to copy the character shapes from character ROM into a RAM location. Now, I've done that in a way in this case that is the same as Supernatural does it, which is not ideal for this case, but we run into some problems that need fixing, and I've fixed that, and I guess it's a good way of learning how to work with the Commodore's memory map. So to change the Commodore memory map, you have to fidget with address number 1, which is the main difference between the 6502 and the 6510 chip, is that this address is present to change the banking. In short, the Commodore 64 has 64K of RAM, but when you start it up, there is basic ROM, and there is the kernel ROM, and there's the I/O registers, and then there's character generator ROM, all layered on top, right? So what we do here is we sort of save the original setting, and then write another value in it that makes the system behave differently. The original value, if you look in the code, is basically this. Like it has a 1 in the third bit, and I make that into a 0. And then all this does is it shows the character generator ROM. Character generator ROM is just a ROM that holds all the shapes for each character that the Commodore knows. They are organized by screen code. Now, there's a difference between Ascii code and screen code. Just like you have ASCII, right? The Ascii table is a standardized table which maps a number to a character shape. For Commodore, Jack Tramiel's son actually is credited for coming up with the Ascii table, so he made his own table mapping numbers to characters. But if you find the number for A, which is 64 or 65, I believe, and you poke that into a memory location on screen, you won't get the letter A, because you cannot poke PETSCII codes to the screen. You have to have screen codes. So in Supernatural, what they did is redefine the character set and moved all the characters to the start of the table. That might confuse a little bit, but that makes it easier, because you can just write a 1, and that'll always correspond to an A, and it'll look like an A on the screen. So that removes that thing. But I haven't done that here. If I'd taken the Supernatural character set, I would have saved myself some trouble, but I didn't. I just copied the original Commodore character set. Right, now that I've confused you all with some some useless character things, back to the code. We've just exposed the character generator ROM, which means that we can access it at the address D00000, or I don't know off the top of my head what that is in decimal. And what I do is I copy that character generator ROM to RAM in memory. I'll talk about where I do that in a minute. So that's what this does. So it sets up the source address. It calls this function copy character set, which basically just copies the character set to a fixed location. In this case, it copies it to F0000. Normally, you cannot do that, because that is where the kernel ROM is, and where all the I/O vectors are, and the IRQ vectors are. But the nice thing is that if you write to that ROM, whatever you write to that ROM is actually passed to RAM, the RAM underneath. If you read from that location, you will get the ROM value. So, but we have to remember how that works. The funny thing is, and that is the next thing, we change the VIC memory control. The VIC can only look at 16K at any one time. So what we do is we set the VIC memory control so that the screen memory and the character memory are in a certain location, and we tell the VIC to look at bank 3, which is like the last section of memory, which means that the display memory is at CC00, and that the character memory is at F00, right? So again, you can tell the VIC chip two things. You can tell it which bank to look at, which is 1 out of 4, but you can also tell it to change the location of where stuff is inside that 16K, which is what we're doing here. So these are all choices that you make when you start writing a game. Basically, you want to reorganize things so that you have a large section of memory available for your game, right? And then you push everything to the back. Basically, that's what it comes down to. So what we've done, we've told the VIC how to look at memory, and we've copied the character shapes from character ROM to the end of memory, of RAM, under the last section of ROM. Right. And all of a sudden, the VIC is looking at a piece of memory and putting that on the screen. So it's going to find garbage there. So what we need to do is fill that section up with spaces. This is the value for space. Screen character memory, if I just point at this, you'll see that it is CC00. That's what we've just set the thing to. So we just copy a bunch of spaces into that memory, which is 1,000 bytes, which we've done right here. Next, I want to put the characters on the screen that will make up our ticker, right? If I go to our ticker, 98, that's where we are now, ticker. I've just defined an array in memory of a couple of characters ending with 2A. That is an asterisk, for those of you who want to know. And I've taken a number of consecutive values, 64, 65. These aren't display codes that we are going to use in this case. I've just selected a couple of them. They are not by accident the same as Ray chose, because I thought, why think about that if I can just follow his example? So this is what I've taken from Ray, right? This just any sequence of screen codes that we're not going to use for anything else, and so that's that. 98. Go back to 98 where we came from. And what I'm going to do is I'm going to point 0 page pointer at that, and I'm going to print that on the screen. This display text routine is from Supernatural. All it does is just copy the whatever it finds at 0 page pointer 1 and put that in the location indicated by X and Y. So what I'm doing here is I'm loading the X register with 1, and I'm putting that in parameter 1 and parameter 2, which are the X and Y coordinates. So it's gonna go row 1, column 1, and then display text. And I'm doing that a number of times. In my example right now, you can see that it prints out only 1. That's because of the one time. That's because of this loop, and I can do that multiple times, which I'll do at the end to show how cool it is to work in this way. So I just put the ticker symbols on the screen, but those ticker symbols, they still correspond with a shape, right? Because we've just copied the character ROM into a new location, told the VIC to look there for the character shapes, and it's going to find the standard characters there. So what we do is we have to empty those shapes out. If I didn't do that, and this you'll see in I won't do that because the program will just run on. Anyway, I could stop. What if I did this? If I just didn't wipe them, comment that out, and demo, jump demo, and run this code, this is what you'll see, right? These are the shapes that I've chosen. If you look at the Ascii table, or if you look at the screen code table, you'll see these characters, 64, 65, and so on. These are their original shapes, right? So this code that I've just commented out, excuse me, that actually wipes the shapes, right? And there's a couple of things that I need to. I wrote this calculate character position because what I'm gonna want to do is I'm gonna want to have a message that I type into the code here, and it's going to have character shapes, right, or character codes, depending on how the assembler processes my message, that I type in. This assembler will, by default, use PETSCII values, which is kind of a pain because they don't correspond to the screen values, do they? So I've had to find a way to change that, which I have. So now, if I look at my message and I check a character, I get the screen value. So that's nice. So if I type in A, I get 1. But what does that tell me? That still doesn't help me get to the actual character shape, which I need to know. Well, I know where the character shapes are. They are at F0000, and I have to calculate a memory position of where that character lives in memory. So this is what calculate character position does. So what I do is I set up 0 page pointer 2 to look at the ticker array, and I'm looking for character number 0. Yeah, and then I say calculate character position. So if I just remember 110, that's where we were. Go to declaration. So here goes. I have to know that from the start of character memory, each character is 8 bytes. So whatever display code I get, I have to multiply by 8. Now, multiplication in binary is the same as shifting bits to the left. Which is fine. I'm going to get a value like 1 or 2 or whatever, and we're going to multiply that by 8. But in this case, the result of the multiplication can be a 16-bit value. So I have to take that into account. This code does 16-bit multiplication, and we'll go through that now. So I'm sure you didn't tune in to to learn about 8-bit mathematics, but it's not that difficult, and I'm gonna talk about it anyway. So here we go. 0 page pointer was pointing at ticker. Y was the index into the ticker character. So we take a character. The accumulator is going to be loaded with the display code, and we're going to multiply that by 8, giving us a value, and we have to add that to F0000, which is the F000, which is the base of the character shape memory. So we have the shape, and we store that into 0 page pointer 2, which is the least significant byte in this case. And we're going to store 0 in the 0 page pointer 3 plus 1, which is the most significant byte. Then we're going to shift the least significant byte to the left, which is multiplication by 2. That will shift out bit number 7 to the carry. Roll, which is a rotate left, will take the shift left will put a 0 in the end where the least significant bit is, and the most significant bit rolls into the carry. Roll takes the carry and puts that into the least significant bit of the most significant byte, right? So you do that once, so that whenever you do a multiplication by 2 of the least significant byte, that overflows, so the value is larger than it can take, the carry will shift into the most significant byte, which is what you want. So you do that once, and you do that twice, and you do that 3 times, because each time you do that, you multiply by 2. If you do it 3 times, you've multiplied by 8. So basically, this is your multiplication by 8 over 16 bits. If the value, if the result would be more than 16 bits, this routine would fail. but we already know that no character is going to not fit into the 64K of memory that we have. So this is never going to get a result that is too large, right? So this is always going to help. So now we want to add the result that is in 0 page pointer 3, the 2 bytes, and we want to add it to F000. So because in the Commodore 64 we cannot add without the carry, and the last operation that we did may have set the carry, and it will add the carry to the result. We don't want that, so before any addition you have to clear the carry, which we're doing. We load the least significant byte into the accumulator, and we add 0, well, because the least significant byte of F000 is 0, so that's what we get. And we store that in 0 page pointer 1, the least significant byte. Then we do the same for the most significant byte, so we take the most significant byte of 0 page pointer 3, which is the result of our multiplication. We add F0, and we store the result in 0 page pointer 1, the most significant byte. So the result of our multiplication and addition will be in 0 page pointer 1, and we return to 110, line 110, which is where we left off ish, which is here. We did so this will result in 0 page pointer 1 pointing to the location in memory where that character shape is. So all we have to do now is wipe that shape, because we were wiping all of the characters in the ticker. And this is what that does. So each character has 8 bytes. So we load a 0, we store it into wherever 0 page pointer 1 is pointing now, indexed by y, which is now 0. We increase y, we compare it to 8. If it's not 8, we go to the next one. So we just wipe 8 bytes. And when we're done, and we can go to the next character. Now we're clearing 11 characters. And the eagle-eyed viewer may have seen that we have only 10 characters in the ticker. My idea is to reserve 11 characters and to have one input buffer character. So what happens is I put a character in there, I roll it to the left 8 times, and when it's done, I put the next character in there. So, and then I roll again, and I put the next character in there. So the input buffer character is going to have a character appear each time. I can demonstrate that in this way. If I made the ticker one character longer, and we would look at the output, you would see, you can see a character appearing here. Bing, 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 bing. It appears there like automatically. It doesn't scroll in. So this input buffer is there, but it's not on the screen. It's not on the screen. So now it's scrolling in. See that? It's a subtle difference, but it's definitely different. Someone sent me a message on Skype. Thank you very much. So I am wiping the input buffer character, but I'm not showing it on screen. Now that we've done that, we can look at our message. Now let's look at the message. Over here, I've defined a message. It says, hello, this is my message, and it has an asterisk at the end, just to indicate the end of the string. Now, if I just typed this into my editor, by the way, I'm using C64 Studio, made by Georg who used it to write Supernatural, which is what I'm using to analyze the code, blah, blah, blah. So this is why the syntax is Acme, which is a cross-assembler which is no longer in development. So it's much wiser these days to use things like Kick Assembler and all that. But I'm not doing that right now. Anyway, any character that I type in here will result in memory, after I've pressed assemble and it's created the program file, will result in the Ascii codes, which I would have to translate first into screen codes before I could use them. And I don't want to do that. Now, luckily, Acme has a conversion table option, a pseudo operator, which is called CT, or conv tab conversion table. And if I put CTSCR in this location, any byte that will be typed into a text pseudo will result in not the Ascii code, but the screen code. Instead of SCR, I can use PET and I can use RAW, which RAW is what I use here to set things back to the way they were. Or I can even define my own conversion table, which is not what I'm doing here. I'm using SCR. I have to remember to type lowercase characters here, but these will be converted in memory into display codes, which is exactly what I want, right? So this is always a source of confusion, this difference between Ascii codes and display codes. Just remember that if you want to get an A on the screen using a poke, you have to poke 1 into 1024. When you boot the you cannot poke the Ascii code. The Ascii code for A is 65. If you poke 65 into the screen, you get a weird character. This difference has always led to confusion. So the lesson is, if you're redefining your character set, make sure that your regular alphabet, like your A to Z, is at the top of the table. Like 1 is always an A, right? So that when you're typing in your development environment, you say hello, and it'll just am I saying that right? Well, just take away the confusion. That's what I'm saying. Anyway, we've seen the message. The message is just a string, and what I'm doing is I've got a memory location that says message index. Of course, I'm going to be calling this from the game loop, so I'm going to be updating this every frame. So I have to write the routine in a way that it realizes that it's being called every now and again. So I have to have a global variable message index, which will remember for me where I am in the message. And we start at 0. Message index. So this is the regular game loop that is taken straight from Supernatural. It has a wait frame which waits for the raster line to reach the end of the screen, so that we can do all our work before the raster reaches the top of the screen, so that there's no flicker. To illustrate the function or the effect of that is that I was in the debugger testing my rolling thing, and I was looking at Vice, but while I was debugging, nothing was happening on the screen, which I thought was weird, because at the moment that you manipulate memory, the VIC will just show the change on the screen. There's two things. One, Vice is, I think, suspended while you debug. Is it? I don't know. No, it's not. But I was doing all the work in between the raster interrupts. Yeah, so all my updates to memory only showed on the next frame. So that's something that's what we're aiming for, right? So that no change happens while we're drawing, because that would cause jittering and weird effects. So every frame we call run ticker, right? Now what does run ticker do? And there we go. First of all, I don't want anything to happen on every frame. I want to be able to introduce a slowdown. This is what scroll delay does, right? I load scroll delay, I compare it to 1. If it's 1, then we can do tick, and otherwise just increase scroll delay and jump to done so that we can do it on the next pass. So if I set this to 5 and press run, you'll see that that it works. It'll just work a lot slower. See? So it waits 5 frames for each update. And each update is 1 pixel. This is my message. Yeah, taking a long time. So I just put this to 1, and so after we've waited a couple of frames, what do we do? First of all, we set scroll delay to 0 because we have to do that somewhere, and we have a scroll count, because after 8 scrolls, I have to put in a new character in the character input buffer. So I load scroll count. If it's not 0, so if we're in the middle of a scroll, then just go to scroll. But what if we've scrolled like an entire character? Scroll count will be 0, so we have to put the next character into the input buffer. So that's what we do. We load Y with the message index, which is our global variable that we just talked about. We point 0 page pointer 2 at the message, and we calculate the character position, which is what we just, it's the multiplication by 8. So we take the next character in the message, and calculate in memory where that is. Now here comes the thing, and this is what I kind of regret about my solution. We want to copy the character shape of the character that we're pointing at into the ticker input buffer. For that, we have to read from the character shapes, but we put that in RAM under ROM. So if we read from that location, we get the ROM value, not the RAM value. For the VIC, this is no problem, right? The VIC can read, it doesn't see the RAM, but the CPU does see it doesn't see the ROM. VIC doesn't see the ROM, it just sees the RAM. But we see the ROM. So each time I do this now, I have to make sure that and that is the same memory location 1. I have to set this bit to 0 to make sure that the area at F000 to the end of memory is RAM, but only for a short time, because there's stuff going on there normally that the program needs. So I suspend all the interrupts. I expose RAM at that point, which no doubt takes time. Then I can say, okay, copy 8 bytes from wherever 0 page pointer 1 is now pointing, which is what calculate character position gave us, which is the memory location of the character shape that we want, and copy that into this location. Now I've given this like a fixed location. This is hard programmed. F250 is the actual location of the input buffer. If you calculate that, it will be 74 times 8 plus F000. That will give you F250. So I've hard wired that in. But I copy the 8 bytes that I find there, and then when I'm done, I put the original value back, and I clear the interrupt flag so that everything is back to normal. I have to do that because otherwise I don't see the character shape. All right. Now that I've taken that character, I've copied it into the input buffer. I can increase the message index so that on the next pass I will see the next character. I load the message index into Y. I check if at that location I see the asterisk. If there's no asterisk, I can just go ahead and do the scroll. If there is an asterisk, then I can just set the message index back to 0. So on the next pass will be at the start of the message. So that basically we're just looping the message. Now, what if we were in the middle of a scroll, or we've done all this work and we can start scrolling? Well, here we go again. What do I have to do? There's this whole ticker, right? This piece of the code is like an unrolled loop. Now, I've heard it being said that unrolled loops are sometimes faster than loops. If you know how often a loop has to do like a branch decision, those usually take 4 to maybe 7 bytes, or was that cycles? Anyway, cycles. They can take a lot of cycles, and if you do that in a loop, it can really count. Now, this is not the reason that I left it this way. This my thought was, if I just write it out first, and then I look at it and I can see sort of what kind of loop I could make out of this. So this could be definitely improved, or maybe this is the fastest way. I haven't even checked, but it seems to work. It just looks ugly, and it takes a lot of space in bytes wise, because this is all there's a lot of commands. But what I have to do, first of all, I have to do that trick to expose the RAM again, because those ticker characters are in RAM, and I have to reach those. Now, I have a load of them in sequence, right? 64 to 74. What I have to do is, starting at the input buffer, which was 250, which is just calculated, F250, and I have to roll that to the left. First of all, I have to realize that it's going to be pushing in the carry, so I clear the carry. I roll everything, and a bit falls out at the end, and it falls into the carry. Then I have to go one character back, and remember that each character is 8 bytes, so we're talking about the top line of all of those characters, right? So F250 minus 8 will give us the top byte of the character in front of that input buffer. And I just roll that, keeping in mind that I want to put the carry in one end, and one is going to fall out the other end, and so on. So they all hand off their carry bits right to the end. So F250, the number of calls here of a roll is equal to the number of characters in my ticker, which is 10, including the input buffer is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And each time I go back 8 bytes, because each character is 8 bytes. So I do that for the top line, but I have to do that for 8 lines. So the first line, the second line, third line, fourth, fifth, sixth, seventh, and 8th line. I just do that 8 times. And after I've done that, I've shifted all of the characters in the ticker to the left by 1 bit, right? 1 pixel. And then I can switch back to ROM again. I've scrolled 1 pixel, so I increase the scroll count. I load it into A, compared to 8, because each character is also 8 bits wide. If I've done that 8 times, then I can say, okay, well, if I've not done that if it's not equal to 8, so if I'm halfway, then I'm done. Otherwise, I have done it 8 times. I have to set the scroll count back to 0, and that will tell me whether or not I have to put in a new character. Right? This is where I do the test for the scroll counts, and that's basically it. This is what happens in each tick of the ticker. The rest is all standard, and that is it. So the cool thing now is that everywhere I put these ticker symbols, it's going to have the same effect. So this is what I wanted to show. This little loop displays my ticker. So if I do this like 13 times, you'll get 13 times the same message. Is that not cool? I can make it longer, I can make it go slower, I can make it go faster, but this is exactly what I wanted to do. So and I can put this anywhere on the screen, and there's no raster interrupt, there's no hardware scrolling. I have a routine. I think it's up on my GitHub. I'm not entirely sure. That does full screen scrolling. This does character scrolling, and because this will allow me to do things like this, right? If I just go back a little, see? That's it. This is Solus 2, by the way, the successor to Solus 1 by Georg and Trevor. So this is it. If you want to look at the code, you're welcome to look at it and to use it. You can fork it and do your own thing with it. It's on my GitHub. I'll leave a link in the description below. And that's it. I hope you enjoyed the video, and I will see you next time. Bye bye.